Slide 1. Introduction. Hi, my name is Anna. Welcome to this journey through futuristic supply chain innovation. Today we are going to study the chapter, which is the role of robotics in warehouse automation. In this chapter, we'll explore how robots are transforming warehouse operations, enhancing efficiency, and redefining supply chain management practices. We'll understand the evolution of automation, types of robots used, their benefits, and real-world applications that demonstrate the power of automation in action. By the end of this session, you'll appreciate not just the technologies, but also the strategic implications for businesses adopting them. Introduction to warehouse automation with robotics. Warehouse automation means using technology to streamline operations like storing, picking, packing, and moving inventory. Since 2015, adoption of robotics in warehouses has been growing rapidly, about 18% annually, and it's projected to reach a $30 billion market by 2026. The COVID-19 pandemic played a big role in accelerating this trend as businesses needed to reduce human dependency. In fact, 67% of warehouse operators reported boosting investment in automation. Automation reduces errors, increases speed, and ensures continuity even during labor shortages. For MBA students, it's critical to understand that warehouse automation is not just a tech upgrade, it's a fundamental shift in operational strategy. The automation spectrum in modern warehousing. Warehouse automation exists on a spectrum, starting with basic to fully automated systems. Basic automation includes conveyor belts and barcode scanners, technologies that assist humans without making decisions. Next are semi-automated systems, such as collaborative robots or cobots that share tasks with human workers. At the highest level are fully automated systems, robots that pick, pack, and navigate independently using AI. Most companies today operate in a hybrid state, gradually moving along this spectrum as technology and ROI permit. This journey must be strategically managed, balancing cost, capability, and operational risk. Types of robots used in warehouses. There are several robotic types based on functions and movement. Autonomous mobile robots, AMRs, navigate freely using sensors, ideal for dynamic environments, and can carry 1,500 kilos. Automated guided vehicles, AGVs, follow fixed paths and handle heavier loads, up to 5,000 kg. Articulated robotic arms are stationary machines used for repetitive tasks like palletizing and packing. They are precise and offer up to 6 axes of movement. Choosing the right robot depends on load types, warehouse layout, and required flexibility. This variety illustrates how robotics is not a one-size-fits-all solution, but a tailored approach to optimization. Emerging robot categories in warehousing. Let's look at newer robot types reshaping warehouse efficiency. Collaborative robots, or cobots, work safely next to humans, taking on simple or repetitive tasks. Their adoption is rising at 40% annually since 2019. Goods-to-person systems bring inventory directly to workers, boosting picking efficiency by up to 300% and cutting walking time by 85%. For example, Ocado's grid system uses thousands of robots to fetch groceries, improving speed and reducing errors. These innovations are not just technical feats, they drive real cost savings and productivity improvements. As an MBA, think of these as scalable tools for solving labor and throughput challenges. Robotics for picking and packing. Picking is one of the most labor-intensive parts of warehousing, accounting for up to 55% of costs. Modern robotic systems now use AI and machine vision to recognize and handle objects of various sizes and shapes. Gripping technology has improved significantly. Today's systems achieve over 95% picking accuracy. This means robots are approaching human-level performance for these tasks. Companies gain efficiency while also freeing up human workers for more complex decision-making roles. Vision-guided picking and multimodal grippers. Vision-guided robots use 2D or 3D cameras to locate items precisely. Multimodal grippers use combinations of vacuum, fingers, and soft materials to grasp different product types. These technologies work together to give robots the dexterity and intelligence needed for accurate handling. They can adapt to variation in product shapes, weights, and packaging. As logistics becomes more complex with e-commerce SKUs, these innovations ensure scalability. Robotic pack-out automation handles boxing, wrapping, and labeling of shipments. This process traditionally required human hands for dexterity, but modern robots are closing that gap. These systems reduce labor cost, standardize quality, and improve throughput. Importantly, they can work 24/7, especially useful during peak seasons like holidays. This shows how robotics extends beyond just movement. It encompasses the entire fulfillment cycle. Key challenges in robotic picking. Despite advancements, robotic picking still faces challenges. Items vary greatly in size, shape, and material, making universal gripping hard. Bin picking, retrieving items from a cluttered pile, requires sophisticated AI and vision systems. Speed is also a hurdle. Robots need to match human rates of 400+ picks per hour to be viable. However, picking speeds are improving by 25% each year, narrowing the gap steadily. Automation of sorting and routing systems. Sorting and routing are now being revolutionized by robotics. Modern systems like cross-belt sorters and robotic arms can process 30,000 items per hour, 10 times faster than humans. These systems read item data, determine destinations, and physically move products to the right zone. They integrate with software to prioritize orders dynamically. This blend of software and hardware creates high-speed, low-error fulfillment operations. Smart routing technologies. Routing involves 4 steps: scanning, decision-making, mechanical redirection, and feedback. Cameras capture item data. WMS algorithms choose optimal paths. Robots direct products, and the system learns from outcomes. The feedback loop improves accuracy and efficiency over time through machine learning. It's a great example of how data and robotics combine to create intelligent supply chains. MBA students should note this synergy as a future source of competitive advantage. The role of AI in warehouse robotics. AI adds intelligence to robotic systems. Machine learning helps with inventory forecasting, path optimization, object recognition, and anomaly detection. Reinforcement learning means robots get better the more they operate, up to 20% efficiency gains in just 3 months. They learn to pick smarter, navigate faster, and handle new conditions. In essence, robots become self-improving assets over time. AI-powered decision-making. AI systems have 4 layers: perception, cognition, planning, and execution. Perception uses cameras and sensors to understand the warehouse. Cognition processes that data to decide what to do next. Planning creates optimized sequences, and execution carries them out with real-time adjustments. This architecture enables complex robotic behavior without human micromanagement. Integrating robotics with warehouse management systems. Robots must communicate with existing systems to function well. The Warehouse Management System, WMS, acts as the brain coordinating everything. Communication standards like OPC UA or MQTT allow robots to talk with WMS and ERP platforms. Middleware helps connect older systems, and APIs make it easy to integrate new robotics. Most companies now use a warehouse execution system, WES, as a control layer between software and devices. The integration architecture integration involves 5 layers: ERP, WMS, WES, WCS, robot-level controls. The WES is emerging as a vital component in robotic warehouses, acting as a conductor for complex orchestration. About 78% of companies adopting robotics now include WES in their tech stack. It ensures robots work in harmony, avoid collisions, and follow business priorities. This architecture is key to scalable automation. Benefits of robotics in warehouses. Let's summarize the business case for robotics. Productivity improves by 300% with 24/7 robotic operations. Accuracy reaches 99.9% thanks to advanced sensors and precision. Space usage improves by 40% as robots can work in tighter layouts. Injuries reduce by 80%, making warehouses safer and more sustainable. These are hard ROI benefits that directly impact operations, costs, and customer satisfaction. Real-life examples of warehouse robotics. Ocado in the UK uses thousands of robots in its grid-based system to fulfill 65,000 orders weekly with 99% accuracy. Amazon operates over 350,000 robots globally, reducing order processing time from over an hour to just 15 minutes. They've also expanded storage capacity by 40% using robotics. These examples prove that robotics isn't optional for large-scale logistics. It's essential. It also creates new business models and reshapes customer expectations.